Okay, so factoring by grouping, okay? Factor by grouping essentially is just double GCF. Okay, so factor by grouping. Your instructions are going to be to factor completely. Okay, so I do want you to factor completely. Okay, for number 1. Sometimes we're going to give you these problems and they're basically almost done for you. Okay, so something like 4 and then in parentheses 3x plus 7 minus y times another 3x plus 7. Essentially, this is like halfway pre-factored for you. Okay, and I want you to think of factor by grouping as basically just like a large GCF problem. Okay, like a really big GCF problem. Here, what would be your GCF? Anyone think they know?
7.
The entire parentheses. Okay, this is one term. This is another one term. Okay, terms are separated by a plus or minus. So here, this is multiplied together technically. So it is one term. This is multiplied together. So it is considered one term. So your actual GCF here is the whole parentheses. Okay, so we're going to rewrite this as the parentheses, 3x plus 7. Then if I factored that out, basically means divided away, if I took out that whole thing, the next set of parentheses is whatever's left behind. So what would be left behind? 4 minus y. That is your answer. Notice, I do not put a square on 3x plus 7. There is not 2 of them, so do not put an exponent of 2 there. That's your answer. You are done. That's it. That's it. That's what we're doing. Now, they're not all going to come to you quite that easy. Okay, they won't all be pre-factored, but essentially it's very similar. Okay, you might have something like this. For number 2, 40d cubed, so 40d to the third, plus 16d squared, minus 15d, minus 6. Okay, 40d cubed, plus 16d squared, minus 15d, minus 6. For this one, what's the first rule in factoring? What do you always want to look for first? A GCF. Is there anything that all 4 of these terms have in common?
No.
No. So if there's not a GCF for all 4 terms, what we're going to look at is trying to find a GCF for just the first 2 terms. Okay? What it would be the GCF for the first 2 terms?
4.
What's the biggest number that goes into both 40 and 16?
8.
An 8. And how many D's do these 2 terms have in common?
2.
2. So 8D squared. If you factor that out or divide it away, what's left behind for the first term? A 5 and a D plus what? 2. Now, the next step is really critical here. You do have to bring down whatever sign this is. So if it's positive or negative, you do have to bring that down. So negative, what's the GCF between 15 and 6?
3.
3. So take out a 3. Then left behind, negative 15D divided by negative 3 leaves you with a positive 5. And negative 6 divided by negative 3 leaves you with a plus 2. Now if you notice, I'm right back to where I started on number 1. I have a common term. Okay, your GCF is again the entire parentheses. So rewrite this, and we're going to make 2 parentheses. 5D plus 2 is one of them. When you factor that out, they go away. And the other set of parentheses is just whatever's left behind. So whatever's left behind is 8D squared minus 3. That is the answer that I'm looking for. Okay, you're always going to end up having 2 parentheses. Now, technically, we do need to make sure that we can't factor this any lower. These cannot be factored any further. Okay, but that is something that you kind of want to look for in some of the parentheses. Okay, let's try another one. Number 3, excuse me. Example 3, 4y, this one's going to be pre-factored for you, times x minus 2 plus 9 times 2 minus x. 4y times x minus 2 plus 9 times 2 minus x. This one is pre-factored for you, but there's something wrong. What's wrong here? What do you see that doesn't work?
The x is negative instead of the 2 on the second term.
The parentheses aren't exactly the same, okay? In fact, they're exactly backwards of one another. So does anyone know, how do you get rid of something? How do I change it to be so that they're exactly the same? You can flip it, okay? If you flip it, that's basically, so if I rewrote this, this would be negative x plus 2. Is it still the same thing?
No.
No. So if I rewrite this, okay, I'm just going to rewrite it because you're almost there. Now, is it the same thing?
No.
No, it's exactly what?
Opposite.
Exactly opposite. How can I make them be the same? Anyone think they know? A negative, right? So what would you do with a negative? You actually don't want to multiply by a negative, but you're actually going to divide out the negative. So if I take out a negative, that's basically saying negative 1 multiplied by 9 here. So you're actually taking out a negative, you're going to multiply it, and this flips to be x minus 2. So instead of writing 9 times negative 1, we're just going to multiply it. Negative 9 times x minus 2. Then if you bring this down, it's exactly the same thing. Now that I have a common parentheses, so the same thing in the parentheses, this is one group, this is another, so your groups are going to be exactly the same. So x minus 2 is one of the groups. These go away. And what's left behind is the other group. So 4y minus 9. X minus 2 times 4y minus 9. Question on how I did that one? So that one's a little bit different since we had to factor out a negative. Okay, next one I'm going to try. Number 4, I would like you to factor 5wh minus 15w plus 12 minus 4h. 5wh minus 15w plus 12 minus 4h. We're going to try that one. So, any ideas, where do you think you begin on that? Is there GCF for everything?
No.
No. There's not a GCF for everything. You're going to look at the first two. What would be the GCF between those first two? A 5 and a W. Okay, left behind in the parentheses would be what? An H minus 3. Okay, don't forget you do have to take out whatever this sign is, so take out a plus. What's the GCF between 12 and negative 4? What did both 12 and 4 have in common? 4. Left behind is what? 3 minus h. These are exactly opposite, so if you factor out a negative, this becomes 5w times h minus 3. If I factor out a negative, that just means I switch this sign. So since it's positive 4, it's going to switch to negative, and I flip it around, h minus 3. So factoring out a negative changes that right there. And that's called an inverse, okay? From here, this is one set of like terms. So take out the h minus 3, and in your other set of parentheses, what's left behind?
5w minus 4.
5w minus 4. That's your answer. 5w minus 4. Anybody have questions on how I did that? Okay, I have just a couple more for you. Make sure you watch these. Okay, example number 5. I would like you to factor completely, and notice I said completely because that's a pretty big deal if you don't. Factor completely. Sorry, I just lost my place. Thank you. Factor completely. Let's go cy squared plus dy squared minus c minus d. Cy squared plus dy squared minus c minus d. So what's the first thing I'm going to look for here? GCF. Is there GCF for all of these terms?
No.
No. So look at the first two. What would be the GCF for the first two terms?
Y squared.
A y squared. Take out a y squared, what's left behind?
C plus D.
C plus D. Next, we're going to take out this negative. Is there GCF between these two?
There's -1.
Just the negative, basically. So I'm going to take out a negative. If I divide by a negative, this will be C. If I divide by a negative, that becomes what?
Positive.
Plus D. Now, this looks a little bit different, but it's really doing the exact same thing. Your parentheses is one set of like terms. And what's left behind if I take these out? Y squared minus a 1. So you do sometimes need to put in a 1 there. Now, am I completely factored? No, now you can do what?
Difference of squares.
Difference of squares. So this one stays exactly the same. Y squared minus 1 becomes what? What does that factor into?
Y minus 1, Y plus 1.
Y plus 1 and Y minus 1. So hopefully after we do these, you'll just start recognizing when things can be factored further. Okay, and I have one last problem for you. Number 6, I would like you to factor 2x cubed plus 2x squared y minus 8x minus 8y. 2x cubed plus 2x squared y minus 8x minus 8y.
Mrs. Cooter, are you going to be here after school?
We can talk. Okay, for this one, where do I start? There is a GCF for everything. What's the GCF for everything?
2.
Just a 2. Okay, the x isn't quite the GCF because there's not one in this last term. So if I take out a 2, left behind would be x cubed plus x squared y minus what? Minus 4x minus 4y. Do you think I'm done? Yeah, not even close. Now, I'm going to take out the GCF again for just the first 2 and then the second 2. So I still have a 2 out here. Notice that it is still just multiplying. Do not put in any plus or minuses here, right? What's the GCF for these first 2? X squared. What's left behind if I take out an x squared?
X plus Y.
X plus y. Okay, what's the GCF for the second 2?
4.
Remember to take out this sign. So minus a 4. What's left behind? X. If I divide away the negative, that would be a plus y. Now, since I started everything off with a big parentheses, I have to close it with a big parentheses. Now, this is one GCF, the whole parentheses. You still have this 2 from the outside. So I have a set of x plus y parentheses. If you factor those out, what's left behind?
X squared minus 4.
X squared and a minus 4. Then what? You can do it again. You can factor again. We still have a 2 on the outside. We still have the x plus y. This one is difference of squares. Okay, difference of squares, x squared minus 4 breaks down to what?
X plus 2, X minus 2.
X plus 2 and x minus 2. So this one you actually triple factored. Okay, that is actually a triple factored problem. Okay, you are going to be working on worksheet 4 today. You only have to do the odds. Okay, worksheet 4, the odds. If you get it done before the end